Hello and welcome to another N-Gen.Math 6th lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 2, Lesson 7 on multiplying fractions. So as always, right, fractions are just another type of number, right? And sometimes they play kind of by the rules that whole numbers do and sometimes they don't. All right, but how we do the standard operations with fractions like adding and subtracting, multiplying and dividing, right, are things that we learn over time. And you've learned how to multiply fractions in previous courses. What we want to do today, especially in the first exercise, is review why multiplying fractions works the way it does. So let's get into it right now. Here we go, the general idea in exercise number 1. The following diagram shows a square meter that measures 1 meter by 1 meter. So it has a total area of 1 square meter. One side is broken into lengths of 1/3 meter, and one side is broken into lengths of 1/4 of a meter. Letter A asks us, if the overall area is 1 square meter, what is the area of each of the small rectangles shown in the picture? All right, let's talk about this a little bit, then I'm going to have you think about letter A on your own. I really need you to understand a very, very basic thing before we kind of get into this exercise. The overall figure that we have here is 1 meter in this dimension and 1 meter in that dimension. And therefore, by definition, it is what we call 1 square meter. All right? Right, that is its area. Not because area of a rectangle is base times height or length times width, but because literally if we have a square that is 1 meter by 1 meter, we call that 1 square meter. All right, so now what I'd like you to do is think about how much area must be in just one of these little rectangles, given that the whole thing is equal to 1. Pause the video now and see if you can write down the answer to letter A. All right, well, it should be this easy. If this entire figure represents the number 1, and there are 12 of these small rectangles inside of it, then each one of them must have an area of 1/12 square meters. And the reason is because there are 12 of them. Right? Now again, this is really critical. This is no different than if I have a rectangle, right, and I've cut it up into 12 pieces and I say, how much is one of those pieces? You'd say, it's 1/12. Now, in letter B, we want to do the following. Shade in a rectangle whose width is 2/3 of a meter and whose length is 3/4 of a meter. What is its area? Don't simplify. All right, again, I'd like you to pause the video now and play around with this. Keep in mind that this side's been broken into 1/3, 1/3, 1/3. This side, 1/4, 1/4, 1/4, 1/4. I'd like you to shade in a rectangle that has 2/3 of a meter on one side and 3/4 of a meter on the other, and then think about what its area must be given your answer to letter A. Pause the video now and take a shot at this. All right, well, let's go through it. Now, it's easiest for us to say, well, on this side of the rectangle, it's very simple to have 2/3 of a meter, right? And on this side of the rectangle, it's very easy to have 3/4 of a meter. So in other words, a rectangle that is 3/4 of a meter by 2/3 of a meter would be shaded like that. Now, what's its area? Well, it's very, very simple. We know that each one of the smaller rectangles has an area of 1/12 square meters, right? And we just shaded in 6 of them. So our area must be 6 times 1/12, or you could write this down right away, 6/12 of a square meter. Right? Now that does simplify, and let's be honest, it simplifies down to the fraction 1/2, But let's not worry about that right now. Remember, what we're trying to do is develop, or at least understand, something that we've seen in a previous course, which is how to multiply two rectangles, or how to multiply two fractions. Not two rectangles. You can't actually multiply two rectangles. Anyway, keep in mind that every rectangle, we can find its area by simply multiplying its length by its width. The rectangle we just looked at, right, has a length of 3/4 of a meter and a width of 2/3 of a meter. Given that, let's take a look at exercise number 3, or exercise C. Since the area of a rectangle is always equal to its length times its width, we can now say that 2/3 times 3/4 must be what? Well, we saw, right, in letter B that the area of this rectangle, that is 2/3 by 3/4, is 6/12. And therefore 2/3 times 3/4 must be 6/12, right? We know area is length times width. We know the area was 6/12, and so 2/3 times 3/4 must be 6/12. But this makes something very clear, right? Where did the 6 come from? It came from 2 times 3. Where did the 12 come from? It came from 3 times 4. And therefore, in letter D, in general, recall that if A over B and C over D are two fractions, then A over B times C over D is equal to what? Well, it's kind of awesome. All we have to do is multiply the numerators and divide by multiplying the denominators. In other words, A times C divided by B times D. Multiplying two fractions is possibly the easiest thing that you do with fractions, right? Because it works the way you want it to, right? You want to just be able to multiply the two numerators and multiply the two denominators, right? It makes your life easy. It would be great if adding fractions worked that way. But as we all know, when you add or subtract fractions, you have to get that common denominator. But not with multiplying fractions. Multiply the tops, multiply the bottoms, and you've got your product. Let's get a little bit of practice with this. All right, exercise number 2. Multiply each fraction and place in simplest form. You do not need to express your answers as mixed numbers. All right, so let's go ahead and do a few of these together, then have you do a few of them on your own just to check your skills. All right, letter A, 7/2 times 4/5. And again, the standard algorithm for multiplying two fractions just says, hey, this is simple. I'm just going to multiply the tops. I'm going to multiply the bottoms. 7 times 4 is 28. 2 times 5 is 10. Now my only issue is whether or not the fraction is in simplest form, and that boils down to whether or not the numerator and denominator can be divided by a common factor. In this case, I can divide the numerator and denominator both by 2, and that gives me 14/5. Now sometimes I'm going to want to change that back into a mixed number, but in this particular problem it says you do not need to express your answers as mixed numbers. All right, there'll be other ones where we're going to want to. Let's do letter B together. Again, very, very simple, right? 7 times 5, all divided by 6 times 8. 7 times 5 is 35. 6 times 8 is 48. And there actually are no common factors of 35 and 48, so that's already in its simplest form. All right, so what I want you to do is pause the video now, take a few minutes to do letter C and letter D. Remember, don't only do the multiplication, but also simplify the fraction by dividing the numerator and denominator by the greatest common factors of the two. Pause the video now and go ahead and work through this. All right, let's go through them. Letter C is a little tricky, and we'll see why. Not really tricky, but gives us a result that's kind of interesting. At least I think it's interesting. So when we multiply the numerator and we multiply the denominator, 5 times 6 is 30, and 3 times 10 is 30. Now, you should never leave an answer like 30 divided by 30, right, or 30 over 30. You might say, well, I'll divide them both by 30, and that'll give me 1 over 1. But that we should certainly make into 1, right? 30 30ths, 7 sevenths, 8 eighths, 10 tenths, right? Those are all equal to the number 1. Let's take a look at letter D, right? In this case, we're going to have 2 times 6, all divided by 9 times 5. 2 times 6 is 12. 9 times 5 is 45. We can divide both the numerator and the denominator by a greatest common factor of 3. And that gives me 4/15 as my final fractional answer. All right. Wouldn't it be great if everything with fractions worked out this way? Oh, yeah, you know, you add 2 fractions, add the tops, add the bottoms. No, can't do that. But multiplying fractions works great. Now, one of the hardest things with multiplying 2 fractions is actually the simplifying part. It's not actually the multiplying part. That's reasonably easy in theory. But then, you know, finding the greatest common factor of the numerator and denominator, that can be a bit of a challenge. All right? So let's take a look in the next exercise how we might be able to handle that. Cross-canceling makes life easier. All right, and we'll talk about what cross-canceling is in just a moment. Let's read through exercise number 3. Consider the product 4/9 times 6/8. Letter A asks us to find the product by first multiplying and then simplifying. All right, well, we just did a set of exercises like this, so I'd like you to go ahead and do that. Pause the video now, go ahead and multiply the 2 fractions together and then simplify your final answer. All right, well, let's do it. Simple enough, right? We're going to do 4 times 6, all divided by 9 times 8. 4 times 6 is 24. 9 times 8 is 72. Now, already, this is a bit complicated. Not the multiplication, that's simple enough. But doing the simplification might be a little bit tricky to think about the largest number that goes into both 24 and 72. Now remember, you can always simplify in stages, and what I mean by that is if you look at 24 and 72 and you say to yourself, oh, you know what, 8 goes into both of them. 8 goes into both of them. Well, you could then divide the numerator by 8, divide the denominator by 8, and that would give me 3/9. Now, the plain fact is 8 was not the greatest common factor, and I know that because 3/9 can be simplified as well. I can then divide the numerator by 3, divide the denominator by 3, and I actually get my simplest answer, which is 1/3. Now, awesome, right? And it works fine, and there's nothing wrong with multiplying the numerators, multiplying the denominators, and then simplifying afterwards. But oftentimes, it's a lot easier to do the simplifying up front with a process known as cross-canceling. Meaning what you do is you look at the numerator of one fraction, the denominator of another fraction, and ask, is there anything that is a common factor of the two that can be canceled out? So let's take a look at that together in letter B. All right, let's do this cross-canceling. Now the way this works is that I will literally look at the 4 and the 8, and I will act as if they are the numerator and the denominator of a given fraction. And what I'm going to do is I'm going to divide both of them by 4. The 4 divided by 4 ends up being 1. The 8 divided by 4, that ends up being 2. Now I'm going to look at the 9 and the 6, and I'm going to say, they can both be divided by 3. Right? And that's easy to see because the numbers are relatively small. 6 divided by 3 is 2. 9 divided by 3 is 3. So at the end of the day, what I now have is 1 times 2, all divided by 3 times 2, which equals 2/6. Now, it doesn't necessarily mean after I've crossed, canceled, and multiplied that my fraction is in simplest form. Obviously, 2/6 isn't actually in simplest form because I can still divide a 2 from both the numerator and the denominator. But that's easier probably than looking at 24/72, that's what it would be called as a fraction, and actually figure out, oh, 24 is the GCF. It's much easier to be like, I can cancel a 4 here, a 4 here, cancel a 3 here and a 3 here. I get 2/6, and then I can reduce that down to the simplest form of 1/3, right? Cross-canceling makes life easier. If there's even any cross-canceling to be done. Many times there isn't. And if there is no cross-canceling to be done, most of the time that means there's going to be very little simplifying to be done in your final answer. Let's keep going and get some more practice with this. Exercise number 4. Find each of the following products in simplest form. You do not need to express them as mixed numbers. Each will give you the opportunity to cross-cancel. All right, well, let's do a couple of them together, then have you do C and D on your own, and then we'll go through them. Letter A, let's take a look. Here we go. So I'm going to rewrite this just so that we have sort of a bigger version of it right here. 5/2 times 4/3. The idea is I would look at the 5 and the 3. There is nothing common to those, so nothing I can do there. On the other hand, the 2 and the 4, yeah, I can divide a 2 out there and I get 1. Divide a 2 out there and I get 2. So that means I now have 5 times 2, which is 10, and 1 times 3, which is 3. And 10/3 is as simplified as it's going to get. Again, it says I don't need to express them as mixed numbers, so I leave my answer as 10/3. Let's do letter B together. All right. 7/6 times 3/10. Again, the 7 and the 10 share no common factors other than 1, so there's no cross-canceling I can do there. But the 6 and the 3, well, I can divide 3 by 3 and I get 1. I can divide 6 by 3 and I get 2. That means in the numerator I'm going to have 7 times 1, which is 7. And in the denominator I'm going to have 2 times 10, which is 20. So I get an answer of 7/20. All right, what I'd like you to do now is pause the video, work on C and D, try to get your answers in simplest form, and then we'll go through them. All right, let's do it. Letter C. Lots of cross-canceling here. 5/21 times 14/15. Let's tackle the 5 and the 15. We can divide 5 by 5 and get 1. 15 by 5 and get 3. We can divide 14 by 7 and get 2. And we can divide 21 by 7 and get 3. Lots of cross-canceling here. So we get 1 times 2 in the numerator, and that's 2. Be careful here. We get 3 times 3 in the denominator, which is 9. 2/9. All right. Simple enough. And notice we got some cross-canceling going on here, some cross-canceling going on there, and we end up with 2/9. Let's tackle D. Let's go over that. Here we have 9/8 times 32/27. Again, we're going to have lots of cross-canceling. 8 goes into 8 one time. It goes into 32 4 times. 9 goes into 9 one time. It goes into 27 3 times. So this is kind of an interesting one. We now have 1 times 4 in the numerators, and that's 4, and 1 times 3 in the denominators, and that's 3. All right, so if you got 2/9 and 4/3 in letter C and letter D, that's a good indication that you know what's going on with multiplying fractions and what's going on with cross-canceling. All right, let's keep moving on. Let's do a little more multiplication. All right, exercise number 5. Find the product of 5/9 with 21/2. Round your answer to the nearest whole number. All right, I'd like you to tackle this. Pause the video now and see what you find. All right, let's go through it. Well, finding the product just means we're going to multiply 5/9 and 21/2. So let's do that first. All right, we have our 5/9 times 21/2. I think I'll see if I can do some cross-canceling. The 5 and the 2, nothing there. But I can divide 9 by 3 and get 3. I can divide 21 by 3 and get 7. All right, so in the numerator, I'll have 5 times 7, which will give me 35. And in the denominator, I'll have 3 times 2, which will give me 6. All right. But, somehow they want me to round 35/6 to the closest whole number, right? That's what it means, right? I'm looking for a whole number without any fractional part that's closest to 35/6. And for that, I really need to turn 35/6 back into a mixed number. Remember how I do that? I just use division. I say, how many times does 6 go into 35? Well, that's 5 times, right? Which leaves me with 30, right? But then, because I have 30, I have a remainder of 5, so I have 5 and 5/6. Now, that's not the answer, right? That is literally what the product of 5/9 and 21/2 is. The question is, what whole number is 5 and 5/6 closest to? It's either closer to 5 or it's closer to 6. But 5 and 5/6 is actually quite close to 6, right? 5 and 6/6, that would be 6. All right, 5 and 5/6 is much closer to 6. It's only 1/6 away than it is to 5. So the correct answer is actually 6. All right. Now, one thing that we haven't tackled yet in all of this fraction multiplication is how, in fact, you would multiply two numbers that are mixed, right? Two numbers that are things like 5 and 5/6. So let's take a look at that in the next exercise. There we go. Multiplying mixed numbers. Well, the plain fact is, since you know how to convert from mixed numbers to improper fractions, right? And you know how to multiply two fractions, then it's pretty straightforward. Let's take a look at exercise number 6. Consider the product 3 1/3 times 6 2/5. Letter A asks us to express both mixed numbers as improper fractions. Now, this is a skill we've been using throughout the unit and that we learned real early on. So what I'd like you to do right now is pause the video and change both of these two mixed numbers into improper fractions. All right, well, it's simple enough. Remember, right, what we've got is we've got 3, which is the same as 9/3, right? So we have 9/3 plus 1/3, which is 10/3. And then we've got 6, which is the same as 30/5. So we have 30/5 plus 2/5, which is 32/5. So 10/3 and 32/5. Now for letter B, pretty much the obvious. Find the product of the two numbers and write your answer in simplest form as a mixed number. All right, so the way that we multiply two mixed numbers is we change them into improper fractions. We multiply the two improper fractions, simplify, and then if needed, we convert back to a mixed number. So take a moment, pause the video, multiply these two fractions together, and then change back into a mixed number. All right, let's do it. Well, we've got 10/3 times 32/5. We can actually do a little cross canceling here. 5 goes into 5 one time. It goes into 10 two times. We then get 2 times 32, which is 64. And we get 3 times 1, which is 3. Now that, of course, is an improper fraction. We want to turn it into a mixed number. And maybe I have to go over on the side of my paper and do a little 64 divided by 3. That'd be 2, right? Which is going to give me 6. Subtract, and I'll bring down the 4. 3 goes into 4 one time. 3, subtract, and I get a remainder of 1. So 64/3 is 21. Whoops, that's not a 21, that's a 27. 21 1/3. Now, by the way, I feel relatively comfortable with the fact that that's 21 1/3. All right, and here's why. I've got 3 1/3, which is relatively close to 3. I've got 6 2/5, which is relatively close to 7. So 3 times 7 is 21. No, so the plain fact is if I had gotten something crazy, like if I had gotten 38, well, that wouldn't make any sense. Or if I had gotten something much smaller, like 5, that wouldn't make any sense. But this really should be somewhere between 3 times 6, which is 18, and 4 times 7, which is 28, right? I can kind of box that product in by thinking about whole numbers that are both less than this and whole numbers that are greater than it. All right, it's a good way to kind of do a little reasonable check on letter B. All right, let's wrap this thing up. So what did we do today? Well, we reviewed the standard algorithm for multiplying two fractions, and that standard algorithm is simply this: multiply the tops, multiply the bottoms. Simplify if you need to. If you're told to simplify, or if you're doing problems where it kind of makes sense to simplify for some reason, then it's pretty helpful to do that cross-canceling up front, where we look at the numerator of one fraction, the denominator of another fraction, and we see if there's any common factors that can be divided out between the two. That simply saves us time towards the end. We also saw how to multiply two mixed numbers together by changing them into their improper number fraction, their improper fraction form, multiply them, and then convert them back. There's a lot of words there. Words. Anyway, I'd like to thank you for joining me for another N-Gen.Math 6th lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.